Connection.
So good day everyone. Am I audible? So welcome to our Google Meet discussion. I am your host for today and we'll be learning about data structure, specifically linked list, stack, and queue. Before we start, let me introduce myself. I am Janar Daleon. So here's our topic or agenda for today. First, we have here linked list. Second, stack, and lastly, the queue. So let's start with the topic linked list. Topic will be discussed by our first presenter. Please introduce yourself and guys, please listen carefully and feel free to take notes.
Good day, everyone. I'm James Tapia, and can you see my screen? I'm here to discuss about linked list. The objectives in this topic, we should be able to learn how linked list works and implement linked list methods in Python. So think of a linked list like a human chain. Unlike an array where everyone is forced to sit by side in a fixed row, a linked list is made of nodes that can be scattered anywhere in memory. They stay connected because each person holds a link or a pointer to the next person in line. This makes the list very flexible and dynamic. So, what is inside a node? Every node has two simple parts. The data, it holds the actual value or data associated with the node. The next pointer, it stores the memory address reference to the next node in the sequence. A linked list starts with a head node, which points to the first element, the last node called the tail, and it points to the null or none to show the end of the list. Here's what linked list data structure look like as what you can see in the image. You can see the image, we have the head, data, which is the node, data next node, data next node, and the null, which is the none. Linked lists serve a variety of purpose in the real world. They can be used to implement spoiler alert, queues or stocks, as well as graphs. They're also useful as for much more. The types of linked list. First is singly linked list. It has one pointer and moves in one direction only. Second is doubly linked list. It has two pointers so we can move forward and backward. Third is circular linked list. The last node connects back to the first node forming a loop. Last is doubly circular linked list. It has two pointers and forms a circular loop. The common operations or the methods we use in linked list. The insertion, which is adding a new node to the list. Deletion, or removing a node from the list. Traversal, visiting each node one by one. Searching, finding a specific value in the list. So let's go on performance or big O nation feature. Accessing an element, insert or delete at start and delete at end, memory efficiency. Linked list. On linked list, accessing an element must walk through the list, while on array directs access via index. On insert delete at start, linked list is very fast, while an array must shift all elements. Insert delete at or delete at end, linked list is on, while on array on if space is available. For memory efficiency, linked list uses more per element extra pointers, while an array uses less per element. Let's go on linked list implementation. So what we do here is we create a node with data and next pointer. Link we created a node here and put a set of data self.next equals data equal and none. Node class creates a node with data and next pointer. Linked list class creates the linked list with a head, add and adds a new node at the end of the list. Show displays all the nodes in order. In the example, we 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 first command link ll equals linked list yeah, and then we second command add and add the first and second. Then we commanded the show, which showed the first, second, and none. Which is I am now open for questions. So let's proceed with the questions. Let's hear from you, Miss Kyla.
Um, unsay naka-different sa linked list from an array?
Oh, um, an array is fixed row of items stored together, while a linked list is a flexible chain of items scattered in memory and connected by pointers for easy adding or removing. Does that answer your question, Miss Michaela?
Yes, thank you.
Thank you, Miss Michaela. Let's proceed for the second question. Let's hear from you, Miss Ira.
So, unsa may mahitabo if ang linked list walay sulod?
You mean empty? The the head is none, or meaning the list has no nodes. If we try to display or access the list, wala siya makita kay wala man siya butang kay empty man ang linked list. Does that answer your question, Miss Ira?
Yes, thank you.
Let's proceed for the another question. Let's hear from you, Miss Anera.
Hello, so our question is, better ba ang linked list for adding and removing data? For
Good question.
removing data ha? Ano?
Good question. For me, yes, because it does not need shifting of elements. It is faster when inserting or removing data. Meaning, di na kita mag-ilis-ilis og elements para add or insert sa or mo remove sa data. Does that answer your question, Nitomo?
Okay, thank you.
I'm still open for more questions. If you have more questions, feel free. Uh, let's hear let's hear it from you again, Miss Mikay. Let's hear from you again, Miss Mikay. Miss Mikay? I don't think Miss Mikay is audible.
Sorry ako. Ano signal kay nawala.
All right.
Na ako'y another question about sa linked list na unsay purpose sa node sa linked list data structure? Unsay purpose sa node?
Node acts a single link in the chain. Stores your data and uh, pointer that tells the list where the next item is located. Does that answer your question, ma'am?
Thank you.
Thank you, ma'am. Let's proceed for another question. How about you, Miss Ira?
So, unsay mahitabo if ang node's next pointer is incorrect?
If node, um, possible ang linked list mag-skips o some nodes like mag-stop siya or mag-create siya og infinite loop nga maka-cause of error during traversal. May tabo if the next pointer node is incorrect. Let's hear from your question, Miss Anera.
So, hello again. So, what is the main disadvantage of using linked list compared to an array?
The disadvantage of using a linked list is slower siya when searching. Kailangan pa man mo mag-go sa node one by one. Like, mo slow mo ikaw compared to an array. Paspas ang array kasi sa linked list. Does that answer your question, ma'am?
Okay, thank you.
Thank you so much. And that's the linked list.
Thank you, James, for that clear explanation about linked list. Now let's move on to the stack, which follow the LIFO principle. Our next presenter will explain this topic. Please introduce yourself.
So, good day, everyone. I am Rania Row, your expert. So, today I will explain ang stacks using linked list implementation in data structures and algorithms. So, after this lesson, you will know unsang stacks and how it works and unsang pag-code niya in a simple way. So, what is a stack? A stack is a data structure that follows the last in, first out, or LIFO. Meaning, kung unsa ang last ni mo gi-add, mao pod ang una ma-remove. Example ani kay ang stacks of plates. Kung sa nang sa ibabaw, mao jud ang imong kwaon. So, this is our stack operations. We have five basic operations, which is push, mag-add og item sa top. Ang pop, it will remove the top sa kuan. So, ang pick dayon, tanawon ang top without removing. And then, ang is empty, mag-check siya kung walay sulod ang stack. And then, ang size, it will find the number of elements in the stack. So, while linked list, pwede ta maggamit og array, pero na limit kay na siya fixed size gikan pa sa start. So kung maabot na ang limit, dili na siya pwede mo dawat og additional elements unless mag-create tag new array. Anya, ang linked list kay mas better kay dynamic siya, pwede mo dako anytime, so dili na ta mag-limit. And then, ang node structure. Ang linked list is made of nodes. Each node has data and a pointer to the next node. And muna siyang chain nga connect ang each part. So for our stack class implementation. Sa stack class, natay variable called top. And ang top, maong pinaka ibabaw sa stack. Siya ang ato ang reference. For the push operation, kay mag-create tawag new node. Then ibutang nato siya sa top. Ang newest element, siya na dayon ang mahimong top. For the pop operation, ang atong tangtangon ang top element. Then, i-move na to ang top sa next mode. Ano siya, i-remove ni mo ang pinakaibabaw yun. Peak and is empty. Ang peak kay tanaw ra sa top without removing it. And ang is empty, mag-check siya kung empty ba ang stock or wala ba siya sulod. For the display chart, kay it's like nag-display gid siya sa imong own tanan elements gikan sa top pa down. Mao ni ang atoang full code. Tanan na kung gi-explain na combine na dayon siya sa whole code ani. Mao ni ang atong kuanon code. Nga example, James ko, tapos si Elsie, and then nanda yun. Mga na to ang fun, guys. Mga na to ang atong code, atong discussion. Open ako sa questions ninyo.
So, thank you for that great explanation, Miss Rania. So, does anyone have a quick question or clarification for this topic? Just raise your virtual hand.
Yes, Miss Meckyla.
Um, kanus ta usually mag-add and remove elements?
We usually add and remove elements sa top sa stacks. Mga na to ang question.
Okay, thank you.
Next question. Yun sa pa, Iera.
So, if ang stack ay implemented siya using linked list, where does insertion happen?
Insertion or push happens at the top, which is also the head of the linked list. Mag-create ang new node, then i-connect siya sa previous top, so siya na din ang new top. Next question. Iera.
So, unsay mahitabo when you try to pop an element from an empty stack?
If ang stack kay empty, wala na siya ma-remove. Usually, it returns none or shows a message like stack is empty. So, importante jud nga i-check first if empty before mag-pop. And Meckyla.
Nakoy lain question and gusto rin ako i-clarify ang ganyan ako na question. 'Di ba ang question ako kay where do we usually add and remove elements? So, mogamit tag method nga add and remove. I
Mm.
just want to clarify. Okay, okay.
Yes.
And napo ko i-question unsay advantage sa ayos maggamit tag linked list sa stock. Unsay advantage niya?
Ang main advantage is iyang dynamic na size. Ang linked list kay dili limited, so pwede siya modako anytime. Nya, mas flexible siya compared sa array nga na-fix nga size. That's it.
Okay,
Next.
thank you.
So, Anera,
So, hello, Ran. So, our question is, why does talk work last in, first out?
because we only access one end, which is ang top. So, kung unsa ang last gi-add, siyang pinakauna ma-remove. Mao na'y tawag na LIFO siya.
So, my second question is, ano, what real life example can best explain how stock works?
Ang simple na example is a stack of books. Kung magkuha ka, sa ibabaw na jud siya. Kung mabutang pud ka, sa ibabaw gyapon mo na ang stack build mo.
Okay, thank you, Ran.
So, ano na ang question, guys?
Yes.
Yes.
So next, we'll proceed to the last topic, which is the queue, which follows the FIFO principle. Let's listen to our next presenter. Please introduce yourself.
So, good day everyone. I am Elsie Calimpon and I will be discussing Q using LinkedList. So, first, the objectives. So, by the end of this lesson, you should be able to define what a queue is, understand FIFO principle, explain LinkedList-based queue, and so we can also implement queue operations in Python. So, first, what is a queue? So, a queue is a linear data structures that follows the FIFO principle or first in, first out, which means the first elements nga na-add is mao siya ang first nga ma-remove. So, in a real life like example, like linya mo sa store or sa any um, like bank ATMs na may magalinya gyud ana and kung kinsa tong first nga nasa linya mo ay like maka um, tawag ani maka-withdraw di ba sa money. So sila ang ma-first nga mag-withdraw, sila sa una ang muhawa. So like that's the queue, mainly point sa queue. So when we implement a queue using a linked list, we use nodes to store each element. So what is a node? A node is a basic unit nga mao ang contains of two parts, which is the data and the next pointer. So the data is the actual value nga stored while the next pointer connects to the next node form siya of chain. So to manage the queue efficiently, we use two pointers front and rear. So what are those two? The front pointers kay mao ang first element which is sila ang ma-first remove. Then the rear points kay mao ang last element where like sila na pud ang new or sila ang mupuli atong front pointer nato nga na first remove. So that's the two. This setup is the allows na ma-maintain ang FIFO behavior correctly. So, for the queue operations, na ay we have two main operations in a queue. So first is the in queue, which is ga-add to new elements at the rear. So, rare, again, is mao ang pinakalasan na to nga elements, di ba? And the second is ang Q, which is ang ga-remove sa atong front pointer. Atong first elements yun na to. So, ang advantage sa using a linked list is that both operation runs in a 0-1 time, meaning they are very efficient since dili na mag-shift dili na ninit ang mag-shift. So, sa oh, I forgot. So, we also have extra functions. The peak, which is manga, allows us to view the front element without removing it. And ang is empty is money ang check if ang queue is 9 elements or wala. And lastly is the is full function, which is ga-check if ang queue kay na-reach na yung maximum size and if the limit is na-set na ba. So, both operations are efficient in a linked list implementation with a time complexity of 0-1 because no shifting of elements is required. So, important concept, when the queue becomes empty, the front pointer becomes none. And the rear pointer niya must also be set to none. So this prevents errors and ensures the queue works correctly when new elements are needed. So let's proceed. Makita niyo yung code, guys. Klaro ba?
Yeah.
Okay. So now let's look at the code. So first is gaseta of class, which is ang node. Mao na siya ang ga-store sa data and ang like next pointer na mo connect sa next node. So, in Q class, we initialize front and rear as none, and we also track the size and optional max size. So, uh, oh. So first is we define the in Q, kay gusto man nato i-check if ang queue is full na ba. So if not, nag-create ta og new node. So, if ang queue mong god is empty, ang both nato nga front and rear will point to the node. And otherwise, we connect the new node to the rear and update rear pointer. Then, pwede na din nato siya ma-increase ang size. Then, okay. Next is the queue. Again, we define DQ. So, para ma-check na to is if ato ang node is empty ba. Okay. If not, we remove that front node by moving the front pointer sa ato ang next node. And point na to is if ang queue na to, guys, becomes empty after removal, we also set the rear pointer to none again. So then we decrease the size and return to the removed value. And the is empty again is to check our node if na ba siya sulod or wala. And again is ato ang is full is mag-check kung nabay or full ba siya or nag-limit na ba siya ang size. And peak, lastly, is a function na simply mag-return sa front element without removing it. So, in a summary, guys, a linked list based queue is efficient because it allows fast insertion and removing using front and rear pointers while maintaining the FIFO principle. So that's all for my discussion. Thank you. I am open now for any questions. Ira, may I hear from you?
So, what is the difference between a queue nga nag-implement siya and og ang queue nga nag-implement siya using a linked list?
Okay, thank you for the question. So, ang main difference between sa how we store and manage the data. So in array-based queue manggod, kay ang size manggod is usually fixed na manggod na siya. So like we need nga ma-define nato siya. We define the capacity beforehand. And also when elements are removed, we might need to shift to another elements or mag-manage na podcast o lain na indices which can be less efficient like hassle siya. On the other hand, if mag-use ta sa queue in a linked list is very dynamic gid siya na function. Kay, meaning it can grow and shrink as needed, and each element is stored as a node and you can use pointers to connect them. So this allows us in queue and queue operations to be done efficiently in 0 1 time without shifting elements. So in short, arrays are fixed and may require shifting, so like aso siya compare sa linked list, more on flexible and efficient siya for dynamic data types. Okay, I hope that answer your question.
Yes, thank you.
Uh, okay, Anera, Miss Mitumog.
So, hello Elsie. So, akong question is, ano, anong QS need magid nato sa programming?
Hmm, okay, that's a good question. So, as a programmer man, di ba, we need queue and programming when we gusto nato nga mag-process ta og data in the exact order and when it arrives sa ato like sa mostly example sa ato ang research paper if like naka-conduct ta og data. So ang queue man god kay mas gina-secure ta niya like fair iyang atong paggamit if magamit ta og queue kay because ang first element na atong ma-add is mao ato ang first na ma-process. Kay since ga-follow ta lagi sa FIFO na principle. And it is important in a situations where ang orders kay ga matter like handling request, task, or data stream. So basically ang queue kay ga-help sa ato ang ma-organize and ma-control ang flow sa ato ang progress sa atong data in a structured and predictable way. So,
Thank you.
any question? Okay, Michaela.
Um, pwede ba ta maka-add and remove from the same side sa queue?
Uh, Unfortunately, no, since ga-follow ang queue sa first in and first out na principle.
So thank you for all the expert for discussing their topics. So just to summarize, linked list uses nodes connected by pointers. Stack follows LIFO, which is last in, first out. And lastly, the queue follows the FIFO, which is first in, first out. So before we end, does anyone have a quick question or clarification for all those topics? If you have, just raise your virtual hand. Miss Mitomog, what is your question?
So, hello mga experts. So, if you're designing a browser history, how can stock be used in this system?
So, a stack can be used in a browser history system because it follows the LIFO principle, which is exactly how the back button works. So, kada mag-visit ka og new page, gamiton nimo ang push sa top sa stack. So, ang pinaka-latest page na jud sa ibabaw. Then, kung mag-click ka og back, ang current page kay i-pop or tangtangon gikan sa top and mabalik siya sa previous page. Then it will continue step by step patras sa imong browsing history. So, mao na siya ang reason nga sakto kayo ang stock gamiton kay ang last nimo gi-visit mao pod ang una nimo balikan. In some cases, na pod another stop for the forward button para kung mobalik ka, pwede pod nimo ma-forward balik ang page. Overall, Stack is simple, efficient, and bagay kayo siya sa browse navigation. Thank you.
Okay, thank you, Ran.
So next question. Okay, Miss Ira Madorable.
So my question is for linked list expert. So if you have a large data set and frequently need to search for specific elements by position, so my question is, would a linked list be a good choice? Why or why not?
Okay, thank you sa imong question. That's a good question. No, to be specific, no, dili siya good choice ang linked list sa imong given situation nga large data set nga frequent pagid ka mag-search by specific elements by position. But let me explain something. Ang linked list kay gwapo ra gamiton if mag-add ka or mag-remove. Kay flexible mangud siya, dali ra nimo siya ma-shift ang elements nya, dali ra ang insertion or deletion. However, kapag imong focus kay search by position or index sa large dataset, dili siya applicable sa imong magamit og linked list sa imong large dataset kay kailangan nimo mag adto sa pinakaunang nga head node tapos isa-usahon na nimong head ang mga nodes nimo antod ma-reach nimo to pinakaubos or target index nimo. Mao madugay mo process if gamiton nimo ang linked list ug dako yung large dataset. Does that answer your question, Miss Ira?
Yes, that's a wonderful
Thank
answer.
you.
You.
Okay, next question. Okay, Miss Meckyla Jacob. What is your question?
For queue data structures, why is a queue is more suitable pang sa other data structures for this use case? If the case is a system receives continuous data like sensor readings and each data point must be processed in the order it arrives. So why is queue is more suitable than other data structures for this use case?
Okay, they give you that beautiful question, Michaela. So, a queue is more suitable for continuous data. It's because processing it follows the FIFO principle, meaning data is handled in the exact order it arrives. So, in a real life scenario, for example, let's think about the fast food restaurant ordering system. Like in a Jollibee or McDonald's, orders come in continuously from, excuse me, from customers, and the kitchen prepares them in the order they will receive. So, if a queue uh, is used, the first customer who orders gets their food prepared first, so which is fair and expected. So if another structure like a stock were used, the most recent order will be prepared first, causing earlier customers to wait longer and creating confusion. So in the same way, in systems that receive continuous data, processing must follow the exact arrivals order to maintain accuracy and fairness and smooth operations. So I hope that answers your questions.
Yes, thank you.
So, thank you everyone for listening and participating. That concludes our discussion about linked list, stack, and queue. Have a great day ahead.